Okay, section 1.6 is representing functions as rules and tables. A function consists of a domain, which is the inputs, which is the independent variable, and the range is the outputs, which are the dependent variable. Now, those outputs depend on what those inputs are, so the range is dependent. To be a function, each input can be paired with only one output. So first, let's learn how to identify the domain and the range of a function. This table below shows the input-output table and the costs of various amounts of regular unleaded gas from the same pump. Now the costs, obviously it depends on how many gallons of gas you buy. So it tells us what the input and output is, so we can then identify what the domain and range is. The domain is the input. So that's obviously the top row. So our domain is 10, 12, 13, and 17. The range is the outputs. Which is $19.99, $23.99, $25.99, and $33.98. And do the same thing right here. We're going to identify the domain and the range of this function. The domain is the inputs 0, 1, 2, and 4, and the range is 5, 2, and 1. We do not have to write 2 twice. Notice I just wrote it one time. That's enough. We don't need to write it multiple times. Okay, so what is a mapping diagram? It's a function that's not written in a table as we've been seeing it so far. I'm going to have the input and output still. Except this time it's going to be in a little box. And it's going to tell you which number goes to where. So let's say our inputs are 1, 2, 3, and 4. And our outputs are 0, 1, and 2. A mapping diagram doesn't just have the pairs like we see above in the table. This time it has a line pointing to where the input is going. So input 1 is going to output 0. Input 2 is going to output 1. Input 3 is going to output 2, and input 4 is also going to output 2. Okay, so now we're going to be able to tell whether a pairing is a function. On the previous page, we had the definition of a function, which is that each input can only be paired with one output. So we need to make sure that we only have one input going to every output, so the inputs cannot be repeated. Is part A a function? No, because we see the input 0 going to two different values. And that's not a function. So we're going to say no. And when you explain, all you need to do is say no, because the number 0 goes to two different values, 2 and 3. It could only go to 1 if it was a function. How about B? This one is a function because no input goes to two different outputs. Let's look at C. Is C a function? Yes, because none of our inputs are being repeated. It's okay that we have two 2's here because we have two different inputs going to 2. We can't have the same input going to two different values. Part D. Is part D a function? No, because we have the value 2 going to two different outputs. So no, definitely not. I do have a spelling error here, so before we talk about this next problem, let's change this word output to input, then this will make a lot more sense. Our verbal rule, the output is 3 more than the input. And there's the equation that means the same thing. Our y, we talked about how that was the output, is, this is going back to a couple sections ago where we changed verbal sentences into equations, is meaning equals, it is 3 more than the input. So if our input is x and the output's 3 more, then that's how we added the 3. Now we have a table, we're going to find those outputs. So if this is our equation, we're going to put all of the different inputs in for x separately to find out what the corresponding outputs are. So the input for 0, 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. And 4 plus 3 is 7. So that's how we would fill that out. Going to do the same thing, make a table for a function. The domain of the function is y equals 2x. 0, 2, 5, 7, and 8 are the domain. We're going to make a table for that function, then identify the range. So if our function rule is that y equals 2x, x being the domain, y being the range, we plug in those different domain values to find out the range values. So this is our rule. 2 times 0 is 0. 2 times 2 is 4. 2 times 5 is 10. 2 times 7 is 14. 2 times 8 is 16. We fill out the table, then identify the range. The range is our new blue values. So 0, 4, 10, 14, and 16 is our range. Now we're going to kind of work backwards. We have the table, and we're going to have to work backwards to figure out what the rule is. So trying to find out the difference, maybe. If we notice anything, the difference between the input and the output, it seems that every time you would add 2 between the input and the output. So it looks like our rule is that the output is 2 more than the input. So if our output corresponds to the y and the input corresponds to the x, output is 2 more than the input. You could also have x plus 2 instead of 2 plus x. So that's our rule. Now we're going to write a function rule for a real-world situation instead of based on a table. If you're buying concert tickets that cost $15 each, you can buy up to 6 tickets. Write the amount in dollars you spend as a function of the number of tickets that you buy. Identify the independent and dependent variables, then identify the domain and the range. So if we're going to first set up a verbal expression, verbal sentence, to use the words first, no numbers. We're worried about the amount that we spent, our total spent. Our amount spent is however much the tickets cost times however many we buy. So now we can plug in numbers where we know them. First, a generic one. A, our amount spent, is equal to the cost per tickets, and we know that's $15 per ticket times N for the number of tickets bought. Well, let's make a table now. That's our function. A equals 15 times N. Now we can make a table based on our independent and dependent variables. Top is going to be our number of tickets, which is N, and the bottom is going to be our amount spent in dollars. That's our A, based on our expression above. So we buy 0, 1, 2, 3, 4, 5, and 6 tickets. If you bought 0 tickets, it would not cost us anything. If we bought 1, it's $15, 2 is 30, 3 is 45, 4 is 60, 5 is 75, and 6 would cost us $90. Now, which one of these depends on the other? Because that's going to help us figure out which one is the domain and the range. The domain doesn't depend on anything. That's our independent variable. So the number of tickets doesn't depend on how much we spend. So we know this one's our domain. But the number of dollars that we spend does depend on how many tickets we buy, which is how we know this is the range. So which one of these is our independent and dependent variables? Domain is independent, range is dependent. And now we have answered all the questions. And that was the section on functions.